Okay, so we are learning how to solve systems of equations using substitution. We have graphed. Now we're going to solve algebraically. We will find that we get the same answer using substitution as we do when we graph. All right, so here I have the two equations, y equals negative 3x plus 5 and y equals negative x minus 11. Notice these are both in slope-intercept form. We could graph these, but we're going to do it algebraically. We do not need a graph, and we're going to see what we get. Okay, so quickly, let's just review our steps. First thing we do is isolate. One of the variables needs to be all by itself. Well, I notice y is isolated here, y is isolated here. So they've been nice to us. They've already done that part. Step one's done. Okay, after we isolate, step two is to substitute. So if y is negative 3x plus 5, that means everywhere I see a y, I can put negative 3x plus 5. So we're going to take this negative 3x plus 5, because that's what y is, and we're going to substitute it into the y in the second equation. When we do that, we end up with negative 3x plus 5 equals negative x minus 11. Okay, so that gives us an equation. So our next step is to solve the equation. Well, we look at this. We've done this type of equation before. We find our equal sign. We can draw a line through it to help us if we want. And we notice, hey, this one has a variable on both sides of the equal sign. So remember, we have to do things a little different when we have a variable on both sides. So we look to find the smallest variable. Here I have a negative 3x. Here I have a negative 1x, right? What's smaller? Negative 3 is. So we're going to do our inverse operation. The inverse operation of negative 3x is add 3x. We're going to add 3x to both sides of the equal sign. We end up with 5 equals 2x minus 11. This ends up being a nice little two-step equation. Now we're going to add 11 to both sides. We're going to divide both sides by 2, and we get x is 8. And we're so excited, but then we have to remember that we are solving a system of equations. We are looking for where two lines intersect. So our goal is a point. We need an ordered pair. We need an x-coordinate and a y-coordinate. What did we just find? We found the x-coordinate. So if we know the x-coordinate and we solve for one of the values, the last step is to find the other coordinate. Okay? Well, if I know what x is, how on earth am I going to find what y is? Well, these two equations both tell us how x and y are related. So look at them and pick which one your favorite is. I'm going to say I like this one, okay? So I'm going to come down here and I'm going to copy y equals negative 3x plus 5. But I just found a minute ago that x is 8. So everywhere I see an x, I'm going to put the 8. So I get y equals negative 3 times 8 plus 5. So that is what? Negative 24 plus 5, and negative 24 plus 5 is negative 19. So when x is 8, y is negative 19. So that means these two lines intersect at the point 8, negative 19, which means we probably would not have wanted to graph these two lines since that's the point of intersection. We would have needed a pretty big graph for these two. Okay? Let's look at another one. All right. Y equals 6x minus 5. Y equals negative x plus 9. That's a system of equations. Where do these two lines intersect? Well, first off, we want to make sure one of our variables is isolated. Notice y is by itself in both equations. Step 2 is to substitute. Since I know that y Substitute. Since I know that y is 6x minus 5, wherever I see a y in the other equation, I'm going to put 6x minus 5. So I end up with the equation 6x minus 5 equals negative x plus 9. Now that I have an equation, my next step is to solve. There's my equal sign. Notice I have a variable on both sides. Which one is smaller, 6x or a negative 1x? Negative 1x is smaller, right? What's the inverse operation? Add 1x. 6x plus 1x is 7x minus 5 equals 9. Now we're in business. Two-step equation. Add 5 to both sides. 7x is 14. Divide both sides by 7. And x is 2. So, recall, we're trying to find an ordered pair. We're trying to find where these two lines intersect. So, we need an x-coordinate and a y-coordinate. We just found the x-coordinate. The x-coordinate is 2. So, our last step is to find the other coordinate. So, look up here. Pick your favorite equation. I'm going to say I like the first one. So I'm going to copy it. And everywhere I see an x, I'm going to substitute a 2. So y equals 6 times 2 minus 5. That's 12 minus 5. And y is 7. So when x is 2, y is 7, and these two lines intersect at the point 2, 7. Okay, this one I want you to try on your own. I want you to look at the two examples we just did. I want you to pause the video. I want you to try it. See what you can do by yourself. Then when you get done, turn the video back on and check your work. Okay, so see how you did. First, I set the two y's equal to each other. Since they're both equal to y, they're equal to each other. Here's where I solved the variable on both sides equation, and I got x was 3. Then for this one, I chose the second equation because it looked a little neater than the top one. And I plugged in 3 for x, and I got y was 4. So my point of intersection is 3, 4. If you have any questions, ask them right now. Get this one figured out before you try the next one on your own. Okay, do it again. Pause the video, try to solve this system, then turn it back on, check your work, and ask questions if there was anything you didn't understand. I got the point 1, 3. Here's where I substituted. Here's where I solved. Here's where I found the other point, and I got the point 1, 3. If you have any questions, ask them, and then you'll be ready to do some practice on your own.